Hello everyone. We are delighted to present our work, MOST, Multiple Object Localization with Self-Supervised Transformers for Object Discovery, selected as an oral presentation at ICCV 2023. This work is done in collaboration with Dr. Ishan Mishra, Dr. Ramachallappa, and Dr. Abhinav Srivastava. Object discovery is the problem of localizing and grouping all the objects in a bunch of images without any supervision. Note that this is not just a region proposal task, but involves identifying semantically similar concepts and grouping them together. So in this example, we discovered 7 objects. Notice that the first step in this problem is to localize objects in all the images before grouping them. Prior work in object discovery have used region proposal networks to localize objects. However, we need supervision to train a regional proposal network. Works like Lost and TokenCut operate in an unsupervised fashion. However, they can only localize the salient object in an image. But most real-world images are cluttered and contain more than one object per image. We propose MOST, a multiple object localization method that uses self-supervised transformers to localize multiple objects in an image without supervision or additional training. We draw inspiration from the observation that the self-attention of the CLS token on the heads of the last layer of a self-supervised transformer trained using Dino can localize foreground objects very well. We make 2 observations from the self-attention maps of the key features of all the heads in the last attention layer of the self-supervised transformer. First, the tokens within foreground objects exhibit higher similarity with other tokens on foreground objects than the ones on the background. Next, the similarity map of the tokens on the foreground are usually less random and localized, unlike the ones of background tokens. Our insight is to identify all the tokens that lie on foreground objects using these observations. How do we pick the right token? To pick the right token, we leverage a technique called box counting from fractal analysis, which analyzes a given pattern with different box sizes to estimate some desired property. In the case of MOST, the desired property is entropy. The idea being, lower the entropy of a similarity map, higher the chances of it belonging to a foreground token. Given an image, we extract features from a self-supervised transformer trained using Dino. Next, we compute a similarity matrix and perform an entropy-based box analysis step. This step identifies tokens which potentially lie on foreground objects. Next, a clustering step is performed to group highly redundant spatially proximal tokens. A connected component-based post-processing step is performed within each cluster to get bounding boxes around foreground regions. Now, we will describe our experiments. The first setup is evaluating the localization methods as region proposals for unsupervised pre-training of object detectors using DETREC. The pre-trained detector is then fine-tuned using all the labels on COCO and Pascal VOC datasets. We observe that MOST outperforms all the contemporary methods comfortably on both COCO and Pascal VOC test sets. MOST outperforms selective search that outputs 30 boxes per image with 2 times fewer boxes. Next, we evaluate the semi-supervised performance by fine-tuning the detectors on k% of the data. We observe that MOST outperforms the other baselines comfortably across different values of k on the COCO and Pascal VOC dataset, with the gap being higher at lower amounts of data. Here, we show the performance of MOST on the task of class-aware object discovery. The features of the regions are clustered using k-means, and object detectors are trained using the clusters as class labels. We observe that MOST outperforms the baseline lost across different values of the number of clusters on COCO and Pascal VOC datasets. Next, we compare the recall of MOST with the baselines lost and TokenCut. The dotted line shows the recall of the original methods. The solid lines show the results of a class-agnostic detector trained using the method's output as supervision. Most and most plus CAD achieves higher recall than the baselines in all the cases. We observe that most, without any training, performs competitively against lost plus CAD and token cut plus CAD in most cases. Here, we show output of most on the VOC 2007, 2012 and the COCO dataset. Most can localize multiple objects of different sizes in cluttered images without any training. Most can also be used for unsupervised saliency detection. In each row, we show 3 examples on unsupervised saliency detection on 3 standard datasets. Most can localize single or multiple salient objects per image. Finally, in the last row, we show a few failure cases where most cannot segment the right salient object. Thank you for watching our video and visit us at our poster on Friday from 10:30 to 12:30 p.m.